So guys, I really want to again welcome you guys and really appreciate you for taking the time to register for this event, and also, the most important thing, also attending the event. So straight to the whole event. So I hope you guys can still see my screen. So I'm moving to the agenda. So for today's agenda, we're going to have introduction of the presenters. So what I will do, I'll introduce myself because I'm the one presenting now. When the others are presenting their section, they will start by, first of all, introducing themselves. I will talk about Graffiland, to be more specific about Graffiland-Lewa. Then, without wasting so much time, we move straight to the main topic of today, which is simplifying statistical analysis. That will be done by Bernard. And we're going to have some tutorials or demo session from Desmond. We have a special package for you guys, so please stay put to the end for us to unveil that package with you. And we have a poll just to have to have a feedback of what you think the whole webinar or event is going to be like. Then finally, there's some closer remarks for us. So there's certain things we also want to unveil to you guys. So that is the agenda. I'll move to the first point of the agenda, which is introducing myself. So maybe I share my screen as well so you can match the face and what you're seeing on the screen and who is speaking. So I'm Ivo Kubam, and I'm a Cameroonian currently residing in Belgium. So this idea of Graffiland, it all started early this year. So I'm the founder with also some other partners. I think So is here, so he's also one of the partners. And currently, I'm the one kind of, the day-to-day activity of the organization. I'm the one really pushing that through. Apart from this organization, I'm also into AI and data analytics. So I'm a consultant and I provide my services to top companies. I've been in this field for over 8 years, so it did not start in Europe. It all started a while back in Cameroon. Away from being technical, so I also love reading. Recently, I've been investing so much of my time and money in reading books around personal development, spiritual books as well, anything that has to do with knowledge. And I also love sharing knowledge. So that's very, very important. The fact that Europe is so interconnected, it's a small continent, technically. I love traveling as well. So that's one thing I do when I have the time at hand. While growing up, I thought maybe I would play for Manchester United, but unfortunately, I'm here with you guys today talking about Graffiland. So it's a pleasure. And recently, I also just kind of engaged into swimming. So whenever I have the time, I go do swimming. So that is that about me. There's more. If you really want to know more about me, you can connect with me on LinkedIn. Just type my name, Ivo Kubam. You see, I'll definitely pop up. Or you can still send me a personal email if you have something personal or something private you want us to talk about. So that's my email on the screen. Okay. So about Graffiland. So what's the vision of Graffiland? So our vision, it's more like we just want to, make African youths globally benefit from the right and deserved opportunities. That was the whole vision about Graffiland. That's how it all started, because me coming to Europe or being back in Africa, there was you could really do more, but you are not really gaining from the opportunities you really deserve. So that is the whole vision about Graffiland. And we want to do this in such a way that our next generation should be able to pick this up and continue from where we're going to stop. So that's why we are looking at something that is going to be progressive and repeatable and most importantly, sustainable. That's why I mentioned that we want our next generation to be able to pick that up. And we want to do that by impacting Africans, so impacting us. Now, most people do have the vision, but sometimes we realize that people have vision, but they don't take actions. They don't have the strategy. So we don't want to fall into that same pit of those guys. So what we want to do is to have an action plan. And what we do is we want to partner with African youths, guys that are having the same kind of ideas with us, that are sharing us the same vision. We want to partner with them. And that is why, for example, today we are partnering with Bernard, we are partnering with Desmond, because we believe that they share the same vision with us. And we have also realized that there are so many talented Africans out there with so much knowledge that they want to share, but they lack the platform. So at Graffiland, what we do is to provide that platform where we bring these people with so much ideas, with that these Africans that are talented, for us to be able to to exchange those ideas and enrich each other. So that is the strategy. That is what we have to achieve our vision. Now, at Graffiland, so what do we do principally? We provide professional education. That's one of the things we do. We are also into AI and data analytics. But today is not the day of AI and data analytics. We want to focus on professional education. So for the professional education service that we offer, it has a special name called Graffiland-Lewa. I'm not going to go into details of how that name came about, but that platform is just an education to professional employment platform. So when you hear of Graffiland-Lewa, think of education to professional employment platform. And the issue we are tackling is the long waiting time. We carried out the study early this year, asking African youth globally what's the average time they spend maybe after graduation before they get into the professional world. And shockingly, we realized that some people on average it's like 2 to 3 years. That is not something we want to keep having, because it makes no sense for you to, after you've spent 3 years of your bachelor's and maybe 2 years of your master's degrees, you have to wait 2 to 3 years before you get into the professional world. That is not what we're told at the university. We just feel like at the university, as soon as you're done with your studies, you'll probably get a job the next day. But that's not what we see in reality. So what's the goal of the platform? The goal of the platform is to empower African youths with real-world skills, with the professional skills and experience that will enable you to reduce that transition time. If it's possible, we want such a way that as soon as you're getting done with your degree or whatever, the next day or the next month, at least you should get into the professional world. Now, we are different, not somehow, we are different in the way we want to tackle this, because we have realized that there are a lot of institutions out there that just focus on the technical skills, but there is a lot involved in transitioning from your education to professional life. And we have decided to put this into a framework called the Education to Professional Employment Framework. So if you see the E to PE framework, it means education to professional employment. And we start with, it could be a graduate, student, or professional. So what is the first phase we usually carry out? We want you to talk to a professional coach. We have realized that a lot of students, even when they are done with, even at the master's degree, they still don't know what they really want to do. I also faced that when I got done with my bachelor's degree. I did biochemistry, and at the end of the day, I didn't want to be in the lab. So I was kind of confused, but I found my way out. But we have realized that a lot of students still face that issue of really what they want to do in life. So we offer that service as well. Next, when you're done with that phase of having a professional coach, we come up with a training plan for you. So with that training plan, and with industry professionals, we do provide, the skills. So we train you with the skills, and we focus on the practical skills, the real world skills, things you're going to see in real world. So industry professionals are the ones offering these trainings. When you're done, one thing you have realized is that even when they say it's an entry job, somehow they still require some job experience. And a lot of students, when they are done with their bachelor's or master's degree, they don't have any experience. So the question is, how can I get the experience? So in this phase of the framework, we provide options where you can actually gain some experience. So that is the third phase of the framework. Next, I keep telling most of the guys that come to me, you can be so talented, you can be so brilliant, you can have 4.0 GPA, and if you don't have the right network, sorry guys, you will not really attract the right opportunities towards you. So at a certain stage, it's not about your brilliance, it's about who you know, because we need to create that professional network. So in that phase, we do what is called professional branding, where we help you in order to sell yourself out there, to market yourself. Last week, we actually did an event around LinkedIn. So we were able to show guys how we can use LinkedIn in order to do professional branding. That is very, very important. And Also, we also help students or graduates or young professionals to get into the job market. So how do we do that? We also realize that the way you arrange your CV, the design, the content of the CV really matters a lot. And with our networks, with the partnerships we are creating with employers and recruiters, it's easy for us to say, okay, this student has gone through this framework, and we are sure that if we like recommend these students to you or these trainees to you, they can actually do the job. So that's what we do at that level of the framework. And hopefully, everything being equal, we hope that you become a professional. But that's not the end of the story. We have realized that when you start your professional life, it's still the beginning. It's just the start of the challenging things to come. So we want you guys to join a professional community. If your job is not challenging, it means it's actually not the right thing. So we expect that when you pick up a job, it becomes challenging. And when you have issues, you should turn back to your community where you feel comfortable and ask questions. Not only asking, you can also give back. There will be students that, they will also need your help. So being in a professional community is you give and you also receive. Okay, so technically, this is what we offer. Yeah, if you go to our platform, to our website, you see stuff around data science, AI, and other stuff that we offer training. But you clearly see that there are other things we offer. So it's not about the technical skills. There's a lot involved. And in terms of our key pillars, I've mentioned we rely on industry professionals. The fact that, for example, I'm kind of providing consultancy services to top companies globally, the experience I have, if I'm to teach, for example, data analysis, it will be different from someone that has not been in the real world to teach you data analysis. I'm not coming to tell you, theory, but I'm going to tell you what it feels like to be a data analyst in the real world. Next, another thing we really focus on, we really encourage is industry certifications. The certification is just more like to attract the right opportunities towards you. If a company is using, for example, Power BI, and you tell them that you are a Power BI certified analyst or certified Power BI user, it makes a difference. It makes some sort of difference, and they can give you that opportunity to go into the next round of the interview. And finally, we try as much as possible to sign contracts with employment stakeholders. Okay, I'm going to end my presentation here, and I'll pass over the mic to Bernard. So Bernard, I think the next phase of this presentation is the coding, which is about simplifying statistical analysis.
So thank you, Ivo. I will share my screen. I think you might see my screen now.
Yes.
Do you see my screen? Yeah. So I'll just a minute. Yes. Okay. So maybe you can see me. I don't know what's the problem, but you should actually see me. But you cannot.
Yes, we can see you, Bernard. We can see you.
You can see me. That's good.
Yes.
Okay. Yeah. So, as to introduce myself, so I'm Bernard Osangir. I'm from Kenya, and I'm currently doing my PhD at University of Hasselt. But professionally, I'm a biostatistician. But now I'm trying to switch angles to bioinformatics. But yeah, that's simply mine. So I also reside in Belgium, and yeah, that is it. Quite brief. And I'm glad to see already a number of people that I know in this presentation. So that's a good thing. And you can actually, I hope you find that this will be an interesting talk. So I don't know if I have to say much. I know I have a few minutes. It's already, time has already gone. So I'll just quickly go through my presentation today about the sample size. So just to point out is that sample size is a huge topic. It's a really wide topic. You cannot really talk about it in a few minutes. It can even take maybe even a week of seminar to talk about sample size, but I'll briefly summarize everything within, let's say, 30 minutes. And then if you have any questions, we will discuss about that. So why are we actually doing this? Is because we expect you to be able to at least understand the phases of a statistical analysis. Also, how you can calculate the right sample size and understand what is the challenges or problems or drawbacks of having a wrong sample size. And definitely at the end, for you to determine the right sample size calculation using R. So to go into the phases of statistical analysis, so usually the statistical analysis are the methods that we use to collect, analyze data, and also interpret data. And there are several steps that are actually under this. So first step is to actually define the problem. So you have to clearly define the research question and the problem that you want to address. And since we are talking about the sample size, this is actually where you also have to calculate the sample size for your research. And after identifying the problem, so definitely you will do all the due processes and start the collection of your data. So you have to gather relevant data, maybe through surveys, experiments, observation, and other methods, and to just make sure that you have correct data to address the problem that you have. So after collecting your data, the next step is definitely do data cleaning. This is we always say this is the step that takes all the time. So you want to make sure that you remove errors. If there's inconsistencies, you can already remove this, and also handle issues like outliers in your data. So the idea is just to make sure that you have accurate data before you go to the next step of real analysis. So after cleaning your data, it's important to do exploratory data analysis. So you want to see what patterns or what relationships are already present in your data. And you can do this by, for example, using plots, graphical representations, and also things like summary statistics to just understand what the data already presents to you. And after looking at some of the relationships or looking at some of the patterns, the next step is definitely to formulate a hypothesis. And this is actually based on the problem that you already defined, based on the problem that you already defined initially, because that's what you really want to address. So you have to formulate your hypothesis. And then the next step is to choose the best statistical analysis for example, to test the hypothesis that you've provided. So there are several tests that you can use. For example, the ANOVA test, you can use t-test, f-test, and so many tests, depending on the question that you're trying to address. And if you've done that, so you have to conduct now the real analysis. For example, if you have to perform modeling techniques and also different models. So they are like if you're working with survival data or if you're working with longitudinal data. So this is where now you can do your test, your analysis. And this is actually almost the same process because some of the tests actually happens after you've done the real analysis or conduct your analysis. So after conducting your analysis, the next step is to definitely interpret your results. So you want to determine whether the results are statistically significant or whether they even if they're statistical significance, whether they're really meaningful results. So that's the next step, and then definitely draw conclusions based on the results and based on the hypothesis that you've already developed. And so this is when you can actually be able to confirm whether you reject the hypothesis or maybe you even want to do further research based on your hypothesis and results. So after that, you have to report definitely your findings to maybe your funders or maybe to publish your results. And this is using of charts, for example, graphs, tables, having reports, and then that's the end of you. But still, sometimes we have people who want to do peer review of your research. So they want to evaluate whether the methodology is appropriate, whether the interpretation of the data, even the conclusion, and sometimes even the citations that you've used in your report. So that's what sometimes people have to do the peer review to just validate that everything, and also getting clarity from your analysis. So this is actually the main focus when people actually doing the peer review. So it's important that before you start your actually like even defining your problem, it's important to always involve a statistician. This will save all the problems, and because we always say, if you bring your data for me to analyze at the end of everything, so it's like if you bring garbage, I'll give you garbage. So to make sure that you don't even waste time or maybe waste resources, it's important to involve statistician your research. Now, to go to what really relates to this presentation, so we have to define some of the important terminologies, like what's the population and what's the sample. So the population defines the entire group that you want to draw conclusion about. So it can be like a population of youths in Africa, and the sample is now a subset of the youths in Africa, for instance. So here you can see that we have a population, which we have different, so we have people, for example, from Cameroon, from Kenya, from Belgium, and then we have to draw a sample from this population. So the number of actually individuals within your sample is what is referred to the sample size, and that's what we will be talking about in this entire presentation. But how do you obtain a sample from a population? So this is done by a process called sampling. So you select individuals from the larger population based on the characteristics and the behaviors that you really want to see in your population in your sample, because the sample should at least be a representative of your population. And this is done by using any sampling technique that you want to use, and you have to also choose the appropriate sampling techniques that you want to use and apply the sampling technique in your population. So this is where you can be able now to select the appropriate sample and obtain the sample that you really want to work with, because the idea of having a sample is to use a small number of or small subset of the population to make a general conclusion about a particular population, for example, we just mentioned it. So what methods are existing for sampling? So we have several methods. So we have broad category of probabilistic methods and non-probabilistic method. So for probabilistic method, we have things like simple random sampling, stratified random sampling, systematic and cluster sampling, and non-probabilistics like convenience sampling, purposive sampling, and snowballing. So maybe to briefly talk about is like simple random sampling is where we consider that every individual within the population has the equal chance of being selected. And for stratified sampling, is the idea is to divide the population into small subgroups, and then based on common or specific characteristics, and then select randomly from this subgroup. So this will actually give you even a more representative representation of your population, because you have subgroups based on different characteristics, and then if you select from this subgroup, you have like the clear picture of your whole population. So we also have systematic sampling, where you choose, for example, the kth member of a population. And this is done by, for example, taking the population number divided by the number of samples that you, for example, guess that you want. And maybe, for example, if you have a population of 10,000 and you want maybe a sample of 100, or you've calculated your samples like 200, so it will be for 10,000 divided by 200, and you get like 50. Or I don't know how much, and then you now select every 50th individual within your population. So after already selecting the 50th, then you also go the next 50th, so the next 100 or the next 150 individual, and that's how you do the systematic sampling. And then we have cluster sampling. So in cluster sampling, the idea is to divide the population into clusters, and then you randomly select a cluster. So now for this is that every individual in a cluster, for example, must be surveyed, or you take these individuals within a cluster and maybe do questionnaire for all of these individuals within that particular cluster. But the cluster we have like convenience sampling, where you select individual that they are readily available or they are reachable. So this is there is no any like chance that is being used here. So if I can reach Ivo, then I'll select Ivo for my research, and that is it. Then we have purposive or judgmental, where there is a predefined criteria that you want, and then you go select individuals with those criteria. So for example, if in the case of rare disease, and you have like, for example, 10 people, then you go for those 10 people and then perform your research on the 10 people that you've selected. And then we also have like snowballing sampling, where also in the case like, for example, a rare disease, you cannot find these individuals. So the moment you have one, maybe they already know other people who have the same disease, and with that, they help you recruit the next person that they know. And that's so we can see that there is no any chance that is which is brought by the probability in this kind of sampling techniques. So then, what is sample size? Definitely. So the sample size is actually just the number that is the number of the individuals within the sample. So that's actually a sample size. And why we want to obtain a sample is to get a representative group of the real population, because you cannot do survey, for example, for the whole population. So it's important to get a sample from this population. And why we have to calculate the sample size is because we have like two main issues. So the first issue, if you have too low sample size, you might not be able, for example, to detect a treatment effect that is supposed to be actually detected within your, for example, if you're doing a new drug test. And if you have too large or too high sample size, you're actually wasting resources. And we all know that research is really expensive. So the idea is to obtain the appropriate sample size for your research. And for example, if you have a too low sample size, and then at the end you have results that doesn't even make sense. In case if it's a new drug, for example, testing of a new drug, and you've subjected individuals of the population of your research into a drug that you cannot even find an effect. So it can bring issues like ethical issues. So that's why it's important to obtain the right sample size. Okay, but how do we do that? So sample size really depends on two types of errors. So for those who have done statistics, we have issues like type 1 error and type 2 error. And type 1 error is just like the probability of finding an effect. So you do a test and you find an effect, which is not even there. So that's the error you give. And for type 2 error is the probability of not finding the effect when it is actually present. So it's slightly opposite of the type 1 error. And for those who have maybe also say, so this is how you represent type 2 error. And the power of your test, or the power of your research, is determined by taking 1 minus the type 1, type 2 errors, which is just the probability of finding the effect when there is actually present effect. And because I've here things that type 2 error depend on, that means also the power of your trial or the power of your research depend on, for example, the significance level, the magnitude of your effect, so the effect size, the variability of the treatment effect, if you're working with treatment, or variability within different groups that you are working with, and definitely the sample size. So this is some of the things that we'll see in the next slide, or how we can use this to calculate our sample size. And just to mention, since I've said that the power or the sample size also depend on the variability. So I will just show you how this is really working here. So if this is a 3D plot, but if you consider, for example, one scale, so if you look at the scale of sample size and standard deviation, you can see that the higher the variability, you actually need a lot of sample size to be able to explain that variability. So if you have less variability in your data, you actually require less sample size. The same way, if you look at the scale of sample size and the relationship with the treatment effect, that means if your treatment effect is large, you actually need less sample size. And if your treatment is actually small, so for example, if it's 1, you actually require a higher sample size because it's actually a very small difference that you want to see whether it's in your data. So you actually require a huge amount of sample size. So this is just how the relationship of sample size and variability happens, as well as for treatment effect. So the best is to have your data with, if you want to have really low sample size, so make sure that the variability within your data is small and the treatment effect is also high, for example. So it's easy to detect that treatment effect. So how do you actually obtain the treatment effect, so, or the effect size? So for example, this is an example of a t-test or a one sample t-test where you obtain the effect by taking the difference between the means, because you are working the sample t-test. So the treatment before difference between the treatment mean, you subtract the for example, the treatment that you want to compare with over the standard deviation of the data. So this is only for example, for a one sample t-test. For other tests, we also have different way where we can calculate the effect size, which I will just be mentioning in this presentation. If you want to look at how we calculate the treatment effect, I'll be mentioning, and you can actually research more about that, because if we go there, then we'll spend even more time. So sometimes if you cannot estimate this treatment effect, so the idea is just to perform a pilot study or look at other background information where they have provided, for example, the means and the variation that you can use to estimate your treatment effect. And sometimes you can actually make informed guess. But if you're making informed guess, it depends on which field you're working. So it might be important to involve an expert in that specific in that field before making the informed guess. So it's important to note that sample size depends on two important things. So first, the sample depends on the nature of your response. So this is the response variable. If it's binary, if it's normal or survival, time to event data or count data. So that's where your sample size depends on, and also the method of analysis. So for example, if you are working with binary data and logistic regression, then we have different way of obtaining that sample size. We might also have binary data on, for example, a 2x2 contiguous table that also have different way of obtaining the sample size. If you have normal in linear regression or normal in the t-test, you also have different ways of obtaining the sample size. So it's important to know that it's the nature of the response that determines your sample size, as well as the method of analysis. So for this presentation, we'll focus at the parametric methods. Not really. Also, we can also obtain non-parametric sample size, but it's a little bit complicated for you to have it presented here. But I mean, you can always research more on this. But before we go there, when working with sample size calculation, there are two important terminologies in hypothesis testing. So we have the null hypothesis and alternative hypothesis. So to a layman language, the null hypothesis is just the boarding state. So the state that you are currently on. And the alternative hypothesis is what you really want to explore. So what is the expected state and what your experiment wants to address. So this is the easiest way to actually explain these terminologies. So now sample size is now trying to look for the number of individuals that will help you be able to achieve, for example, the expected state. And if you cannot achieve, then you have to, say it doesn't work, you stay in the boring state. So we'll see how this happens in the next slides. So for normally distributed responses, usually we work with means. So if you want to, for example, check the difference of means between two groups, so the boring state that I've mentioned will be that there's no difference between these two groups, but the alternative would be like, hey, the two groups are different. So that's where you actually base your judgment of your sample size calculation is. So to look, for example, for normally distributed tests, for example, one sample t-test. So you can see that, as we mentioned, the response and the method of analysis. So the response here is a continuous response, and the test is we want to do a sample t-test. So, and it's a one sample t-test. So the idea is, how can I do this? Because we want to check whether the new, for example, the group we are like, maybe for example, the BMI of women is different from what was reported maybe 20 years ago. So maybe if the BMI was 25, maybe 25 is in 20 years ago, you want to see, hey, scientists say, yeah, at the moment, the BMI is actually different from what was reported 20 years ago, and that's what you want to test. And here I've provided like a formula of how you can do that. So we have you only need to provide the Z alpha, so that is Z score of the significant level, and the Z score of your power, divided by the effect size. And as I mentioned earlier, that different methods have different way of calculating the effect size. So for this case, they use what I showed earlier, the difference between the mean that you want to test minus the mean that is already existing divided by the standard deviation. So this is just the normal Cohen D that you use in determining the effect size. So you don't have to really know this by heart, but if you really want to, then you can look at this move. And if you want to do this in R, so I've provided an R script here. So you have to provide the D here is the effect size that you have to calculate or you have to estimate, and then provide the type 1 error. So that's the significant level. The power is, as I mentioned, is 1 minus the type 2 error. So here type 2 error is 10%, but you want your study to be able to have 90% chance of detecting the effect when it is exactly existing within your research. Then, because it's one sample t-test, I have to provide type that I want one sample t-test is one sample, and then because the way we've defined the alternative hypothesis that the mean is not equal to what is existing already. So that's a two-sided test, but also have a one-side test saying that the mean is greater than the already reported mean, or you can also have that the mean that is existing is actually lower than what is already existing. So if you do that, if you provide what I've said, for example, you want to check effect size of 0.2 and these parameters, you will get that you have a sample size of about 264 point something, and it's always important to round off. So you have a sample size of 265. And it's important to note that if you have now the greater, you want to say that the mean is greater than that, you have to just change the alternative to greater. And if the mean is less than the already reported mean, then you have to change this to less than, but also you have to change this value to a negative sign. So that's important to note. If your interest is difference in means between two groups, so you can also remember that this is a continuous response and it's still t-test. So we also have different formula. So we have here first shown the difference, when you have equal variances between the two groups. So why it's actually this is because you have, I've tried to explain here. So you have, you have equal sample size, so it's like 2 sigma squared, because you have to provide the variability for the two groups. So it's like sigma squared plus sigma squared, so it's 2 sigma squared, and that's why you have 2 here. And in case you have an equal sample size, so that 2 will go, and actually you have now the summation of 2 variability of the two groups, and then divided by the means of the two groups squared. So that's what makes the difference. So if you have equal sample size, so this is just be 2 sigma squared, and then the 2 comes in. So for example, to show if you want to check, for example, the difference between the BMI of young women and young men and women. So again, you have to calculate the effect size. And as I mentioned, it's just you for sample details, you use Cohen D, so you can look at it. I could not provide every information here. And then provide a significance level, your power, and then because it's 2 sample size, we have to say our type is 2 sample size here. And it is two-sided because now I'm assuming we've mentioned that the difference, so the null hypothesis would be like the mean of BMI for women and men, they are equal, so that's the boring state. And then the alternative is that the mean of men and women, they're actually different from each other. That's why you use a two-sided test. If you say that the mean of men is greater than women, then this will be greater. And if you say that the mean is less than, then this will be less than that. So if we do this, you obtain a sample size of 526. So you have to round off like 527. And then because this is for each group, you have to multiply by 2 because we have 2 samples. So each group will have 527 as a sample size. And again, to mention that if you have a greater as an alternative, you have to provide greater here. And if it's less than, provide here as a less than. And remember that if you're using less than, you have to provide the effect size as a negative sign. So we also have paired details. So for example, you checking the BMI of women, maybe between 2 different time periods. So that's the paired details because the information coming from the same individuals. So you have to change this type to a paired test and then two-sided and also obtain the sample size for that respective type of analysis. Okay, now what happens if we have more than 2 groups that we want to compare? So we'll basically use ANOVA, and you can also see that the response here is just a continuous response between different groups. So it's continuous within groups, and then the method is ANOVA, so the method is also different. So we have also different way of calculating the sample size. So the null hypothesis is that, hey, there is no difference between, for example, different type of the weight of different, for example, weight of different dogs types or something. So that will be the null hypothesis, and the alternative is that at least one group mean is different from the rest or from the other. So that's in another problem. And how you do that is that you have to know how many, this K is the group, the number of groups. So if you have, for example, the breeds of a dog, maybe say I have 5 breeds, so that will be, K will be 5. And then F is the effect size. So you want to say that there's at least one mean which is different by 0.5%. And for you to calculate this effect size, you have to use the sum of squares differences. So the sum of squares between the groups over the total sum of squares. So you can also look at how to do the effect size calculation in ANOVA. But if you are using R, you'll use a package. So the package is actually called PWR, where you'll just now do power.ANOVA test and then provide a number of groups. After calculation, you are calculating your effect size, provide the effect size, then significant level, and the power of study. So here I've put power not from 90, but now 80. So I'm allowing more error for type 2 error, because it's also important to note that the higher the power, the more sample size you actually require to be able to even discover, have high chance of discovering the effect size. So if you provide these parameters, it tells you that we have case 3, for instance, we need 13, so about 14 for each group, because there are 3 groups, so you have to multiply that by 3 to obtain the total sample size for in another problem. And what happens if you have the different in proportion? So you want to compare maybe difference in proportion between 2 groups. They also have different variables. So here the response would be proportions, so the probabilities, and then you can use 2 proportion test, where now you can see, because there are 2 proportions, they also depending on the probabilities between the 2 groups. So here we have the Z alpha, so the Z score of the level of significance. Then we have the Z score of the power. And you divide by the difference between the 2 probabilities of success, in this case, multiply by the sum of the variances of the 2 groups. And that is it. So if you have R, you don't have to do all manual calculation. You just have to provide what's, so this I've used power.prop.test. This is under our package called stats. So our package stats, where you have to provide the probabilities that you want to, that is existing. For example, probability of women who are smoking and the probability of men who are smoking. Then provide the same information, level of significance, power. And if your hypothesis is that there is no difference between the probabilities and or the proportions, and then the other one, the alternative says that there's difference, but without any direction, then you have to use the alternative as the two-sided as the alternative. Then if you plug those parameters, then it tells you that you need a sample size of 388, and this is for each group. So you need, if it's 2 groups, because you're doing difference between 2 groups, you have to multiply by that by 2. So you'll have about 700 and something as the number of your sample size. Sometimes you want to just do the association between, for example, 2 groups. So like, for example, female, gender, and okay, let me say sex and smoking. So you want to do the association, and you want to just do a basic chi-square test. How do you do that? So first of all, it's just, this is just a 2x2 contingency table. And
what the hell?
So you have 2x2 contingency table. And so from the same package of power, you have to provide the effect size. So here the W is the effect size, which is calculated. So it not to just mention is that no. So it's just the effect size. Then you have to provide a degree of freedom, significance. So most information is just the same information that you want. The only difference is maybe the test that you're using and the effect size, how it's calculated. So in this case, the effect size is calculated by using the chi-square that you obtain from, for example, a pilot study, where you just take the sum of the difference of the sum between the expected and observed divided by the expected value, and then you obtain the effect size that you want to test. And by doing that, if you use R code, it's quite easy. You just provide the parameters that you have, and then you have N, and then this is the number of observation that you require in a 2x2 contingency table to do your chi-square test of association. All right, so sometimes you also want to apply a linear regression to check the relationship between the response and maybe 1 or 2 variables. So for example, for a simple regression, it's just a relationship between your response and one explanatory or independent variable. And if you have, for example, 2 explanatory variables, then you'll have a multiple regression that you have 2 explanatory variables or independent variables that you want to check how they are relating with your response. And then that is it. So how do you obtain the sample size for this? The formula is quite complicated. If you want to determine the effect size, you use the R squared. So that's the goodness of fit if you're doing your linear regression, or is just taking the square of the correlation of coefficient, then you obtain the effect size. And then the idea here is if you're using R-test, you're using actually degrees of freedom to obtain this sample size. Why we do that is because so we have two different degrees of freedom. So we have the U, which is the numerator degrees of freedom, and numerator degrees of freedom are actually the degrees of freedom which represent the number of independent variables that you have in a regression model. So for example, except the intercept. So you have two explanatory variables, so 1, 2. So in this case, you'll have 2 as the numerator degrees of freedom. And then V here is what we actually want to determine, which is the degrees of the denominator degrees of freedoms. And the denominator degrees of freedom actually stands to the error degrees of freedom, which represent the number of observations within your sample after you've subtracted the degrees of freedom representing the independent variable. So in this case, V will be all the i's in your data minus 2. So in this case, and that's what we actually want to determine. So we want to determine what is our V in our research. So by that, you can do power.f2.test, where you only provide, for example, in the case of a simple linear regression, that you only have one independent variable, so provide that u as 1, then the same information, power, significant level, and I mean, this is the effect size that you've calculated, then and remember, this is what we saw. This is the R squared, so the coefficient of the correlation coefficient squared. So this is the F2 and then power. And then if you do that, it tells you that the numerator degrees of freedom is 1. So that means you only have one independent variable in your model, and your N, your V, which is the numerator, and we say the numerator degrees of freedom is the number of information in your sample minus 1 in this case. But you also, so when you do that, you have to obtain this 10, which is now the degrees of freedom, the denominator, and then you have to add 2. Why you're adding 2? Because you're actually losing 2 degrees of freedom in explaining your response and explaining your explanatory variable. So a little bit of a complicated approach there. So, but here is the formula. So if you have, for example, in this case of a multiple regression, you have to provide your U as you have 2 independent variables, and then you determine your V. And then when you get the V, you have to add now, for example, if the V is 10, you have to add the 2, which is now your U that you provided, plus 1. So there's some mathematics behind it, but yeah, so the simplest way to understand is just you're using degrees of freedom, and you have to understand what degrees of freedom represent your data. So that is the V, which is the denominator degrees of freedom. So in the case of logistic regression, so you have a binary response in this case, and you want to see the relationship between your binary response and the explanatory variables. So here I've shown a simple example of a logistic regression where you have two independent variables, and how you can obtain the probability of, for example, having a disease. So this is like 1, and this is 0, not having a disease. So the probability of having a disease is 1 over 1 plus the exponential of negative the parameters in your model multiplied by the independent variable. And so to obtain this is also a little bit complicated, but we have a help of web power package in R, where you have to provide. So for example, if you are comparing So for example, you're comparing the probability of having the disease during in your trial and what you already expected to have in your trial. So you have to provide like, hey, the probability of having a disease when I have these explanatory variables in a model will be 0.35, but previously, for example, it was 0.25. So you have to plan this in your R code, then provide the same information. And if it's two-sided, saying that the difference is in any direction, and then the family-wise. So this is normal, but it doesn't mean that it's actually binary. No. So this is normal for, if you try to change this to binary, it will tell you that there's an error in that section. And if you do that, the result is that it will provide you the probabilities, the estimate of your, so these are the beta 1 and the beta 2 here. So these are just the initial estimates, and then it will give you the sample size here. So now you can round off this to like 202 as your sample size for this kind of logistic regression, depending on these parameters P0 and P1. So you can look how to do this for Poisson. It's interesting, but there's a lot of calculation that you can actually do that. So we've talked about the simple tests and simple sample size calculation for simple methods and simple responses, but there is also under advanced methods that you can actually do sample size calculation that we cannot discuss here. I don't want to scare you. Yeah, but then we have like advanced methods like in structural equation modeling. So that's the same, where the sample size actually depends on the model complexity, the power, and the effect size. But now calculating this is some advanced statistics. For example, in longitudinal study, so this is where you observe the subject, for example, over a period of time, and it actually requires special consideration for sample size. So it might not even need calculation, but you have to also make discussion between you and experts of how to use what information you actually want to obtain and your power of your study and so on. So we can also we cannot discuss that here. Also in survival analysis, so it has also its own way of sample size calculation, and this is majorly based on the hazard ratios, for example, the expected hazards within your time to event responses. And also Bayesian, you need to provide some specific priors and some information which you have to discuss with the experts when you are calculating the sample size. So we cannot discuss this here, but if you want more discussion of this kind of sample size calculation, then we can actually discuss it in a later talk. So what's the take-home message? So it's important to have the right sample size. Because the little sample size can actually lead to unreliable results, and it's also will make it not easy to detect the treatment effect or the effect that you want to observe. So the sample size, enough sample size or the appropriate sample size will give you the probability of detecting the effect when there is actual effect. And also it will give you a representative information of your population that you've drawn this sample from. Also, it will give you, so there's a lot of precision if you have enough sample size, because the idea is to have as much accurate information or precise estimate instead of having a low or high sample size, which is just wasting of resources. Also, for reliability aspects, so having enough sample size or appropriate sample size will make your research reliable within the scientific community. And if when they are replicating it, so they can see that, and if they might even have confidence in your research. And also for ethical consideration, we said you don't want to expose individuals to a new treatment, for example, and later discover that there is no much information to discover the treatment effect. So it will also help us to deal with ethical consideration and cost efficiency, because we'll save more instead of having high sample size, having appropriate sample size will give us what we need instead of having high sample size. So, and also scientific credibility, I've mentioned individuals who wants to, for example, do peer review for your research will have more confidence in your research than when you have a little sample size and then nobody will even believe in what you have reported in your findings. So that is it. I have a lot of materials for you if you want to read more, for example, on the packages like Power, Web Power, and also they have manuals and really good examples of how you can calculate different sample sizes with different methods and different techniques. So this will be really important if you want to dig more into sample size calculation. And that brings me to the end of this long presentation. About 50 minutes. So I'm sorry for taking too much of your time. But if you have any question, you can definitely ask. Or maybe Desmond can already go through, then we can have the question at the same time. I don't know what's your take, Ivo.
I will suggest that we take some questions now because I think someone already raised up the hand. So maybe 1 or 2 questions for Bernard now. We'll see if maybe after Desmond presents, we can have see another session. So if you have a question, please feel free to unmute yourself and throw the question.
I've got a question here. It's Alemgo Nicodemus. I'm just wondering to what extent or how correlated is the how correlated is the power calculation which you just presented with respect to the linear regression to the coefficient of determination?
Yeah, that's a really good question because so when we really check most of the times when we want to see whether our, for example, linear regression or even multiple regression is somewhat appropriate or it's actually doing better. So we always look at the R squared or the adjusted R squared. So we can see that we have, so that's just the variable explained by your model, for instance, right? And we've seen that variability actually depends on your power as well. If you remember the first slides that I presented earlier on. So there's a relationship between variability and your power. So the more R squared that you have, the higher I squared, for example, of 80%, that means your model is explaining 80% of your, for example, the variability within your data. Because I mean, statistics is all about explaining the variability that you have in your data. So 80% that means there's a lot of information that the model is explaining, and that means your research is actually having a power to identify or to explain for 80% of the variability in your data. And that means if we have that, we can actually, it's like going back in a reverse to now see how much information, how much sample size we will need to explain 80% of the variability within our data, which is just really having a relationship with your power of your study. I hope that's clear.
It's okay. Thank you.
Yeah. Okay.
Okay. Thank you. Miriam.
Hi, Mr. Bernard. Thank you very much for the very wonderful presentation. Lots to learn, lots that we've learned. I was wondering, because sample size is related to power, and one of the things that you were providing in your code was the power. So if, for example, I already have a sample, when we do secondary data analysis, we already have the sample. How can we use some of these functions that you provided to us to know if with the sample size that we have enough power, like the connection between, like going back from sample size to power as opposed to now power to sample size?
Yeah, so thank you, Miriam. Yeah, that's a really good question. You can do that First of all, because if you are using secondary data, somebody have already provided with you information about, for example, what parameters they used, maybe what significance level they used when calculating the sample size. What also, for example, the initial values, for example, the initial estimate or guesses of your initial guesses of your study. So, for example, if I show a formula, so somebody has provided you with, I'm using my, so somebody has provided you with the D, so the effect size. You know that what significant level they used, and then this you can actually go back and actually be able to calculate what power is. I know there's a formula, for example, because if you look at this formula is actually power.test, so you can actually plunge in all these values. I'm trying to remember which R code that can actually do that, but it's really possible. So for example, if I show you the sample, the proportions. So if you go, for example, for proportions. So for example, here for proportions, I provided null as the sample size. So you can actually, this is our interest. But now if you want to go back to obtain the power, if that means you already know that this study, they used, for example, N200. So you'll use here as 200 and then provide all the parameters they provided. But now for power, you actually now use null. So based on these parameters, you can actually obtain the null. But if you want to use the formulas, that means this is what you want to find. So you'll have to provide your 200 here, and then provide the red alpha, the probabilities that they used for the analysis and the variability, and then just obtain the reverse of the z-score for your beta, and then you'll get the power of your study. So it's just about like reversing the whole process, which is really possible. There's a function in R that can do that. I will look at it and maybe share with you as well, but I cannot really remember it offhand.
Okay, thanks. I would suggest that we move on to Desmond, and if there are some other questions, we can take them alongside the other questions. So, Desmond, are you ready?
Yes, I'm ready. Hello to everyone. Thank you, Bernard, for your wonderful presentation. And I think you've really gone so deep and discussed a lot about sample size calculation, giving us an insight to actually understand that, you know, for you to start your research, taking into consideration how you calculate your sample size, you know, it's an integral part of how you get your results and how credible your results will be. So, and if I'm following up, you know, he has explained almost everything. So I'm just coming in to throw some light on the codes and how practical this can be in R. So I'm Desmond, and I'm presenting from Cameroon. I'm a biostatistician as well, and with a background in molecular biology. So I'm very enthusiastic about R. So it's a software I've been using for quite some time now. So I'll just move into R Studio very quick and show you some of the codes, which of course these are codes that you already had on the slides, but I just want to show you how we can run this on the software. But just for a selected few of the statistical tests, we'll not run through all of them for time constraints. So I'll select just a few of them and how we can in order to successfully get this sample size. Because I think Bernard demonstrated the mathematical components behind. So with Aru does the math. So all those formulae you see on his slides, when you're doing this in Aru, it takes all of that into consideration. So all you need to do is just to have your code well written, and when you run, you want to have.
Are you sharing your screen? I don't see.
Studio. My Studio.
Yes.
Ivo, I don't know if my Studio is visible.
Yes, I can see your screen. I can see your R Studio.
Okay, great. So let me just turn off my camera so that I can maximize the bandwidth. All right. So if we look at my R, so first of all, why R? Why do we choose to use R for this analysis? You know, R is just one of the many softwares, but I prefer R, and I've been using R for quite some time now, and it's one of the most widely used softwares in the world now, in both the field of engineering as well. So about this software is that it is free. You know, it's an open source and very free software. The setup before installing setups that you might want to buy, but the software is free. So if you just go to the website, you can be able to download the software free of charge. And you know, and this software has a user-friendly version, RStudio, which is what is demonstrated on my screen. And with RStudios, they have some other functionalities, and it's more user-friendly and flexible in such a way you can be able to, you know, switch from there to other softwares and, you know, import data, save your scripts, and, you know, transfer the scripts on different platforms, and even send to someone, you know, via email, so that they can be able to have access to. And you know, having a good internet is not necessarily a prerequisite for using the software, but then it's important to have internet such that you can be able to seek some do some more findings while you're working with the software. But when you download and install the software, you don't necessarily need to use an internet connection. Okay, software, you know, which you can be able to use, and is capable of providing some automated research. And so on my studio, on my screen, so normally when you download RStudio, you have something like this. You have a screen, you know, which is normally empty. Mine has codes already. So, and if you look at the windows, so when you install the software, you have something like, it looks like you have 3 windows, 1 window on the left and 2 on the right. But actually there are 4 windows in this software. So the window on your left, you can be able to divide this window into 2, where you have, this is what we call the source, where you can type your codes, right? So this is where you type your codes and you can save them. And normally the window on the top right, by default, when you install the stuff, to switch the console this way for mine, because it's more flexible for me analyzing here and viewing my results this way. So this console, this is where, you know, where you run a code here, you can actually get the results I have here. And then we have the bottom left, which normally by default is on the top right. We have the environment and the history, where some codes are being saved, like you track back the history of things you've done. And when you plot graphs, for example, you have the graphs displayed on this bottom right screen, or bottom right window. And also here we have another function for packages, where, you know, so these packages, we'll see how these are being installed. So a package, this is simply where particular analysis have. So in such a way that if you want to do a particular analysis, you know, these functions have been coded, and you download this package from online. Download a particular package from online, you don't necessarily need to download the package again. So one of the times where you use R online is when you want to, there's a library of packages. So when you download the package, it's saved in the library, which you can be able to call it up from the to use at any point in time. If you wanted to run an analysis that it's a particular function that has been encoded or stored in that particular package. So you have quite a number of them here. There are packages that can use for plots, like we see packages that will be used for sample size calculation. There are packages you can use for survival analysis, to calculate odds ratio, and so on and so forth. So, you know, for data cleaning or data wrangling, there are packages that you need to install for you to effectively clean your data and all of that. So, and of course, up here, we have options where you can save your script. You know, if you click here, you see options like our normal Microsoft. And so the software you can be able to play and programming languages, how good you can master programming language you can be, or how inquisitive you can be. When you open some of this software, you need to play around with it. You know, the more you use them, you know, I usually say programming is like you want to learn a new language. If you want to learn Chinese, for example, it's not what they teach you in class, for example. It's based on how many times. So the number of times you open the software and you try to use it, that is how you keep learning new things. And because it's very practically impossible for someone to say, I want to teach you everything in R, you know, because there are a lot of functionalities in the software, which as you keep using the software again and again, you tend to discover a whole lot of things. So here are just some codes which I already have, which what we'll do here is to run the codes, explain a few things, and you see the results as explained by Bernard. So there are some important packages that we need to use in order to do sample size calculation in R, irrespective of, you know, based on the different statistical tests that you intend to use. And so there are three packages which I installed here: the power package, the stats package, and the web power package. So these packages, for you to install them, you need to connect your computer to the internet, and you use this code. This code called install.packages. This is just one of the ways by which you can install packages. You can still install from other point and click options. So if you type install.packages, and in bracket, you put the name of the package in quotes. And if you're connected to the internet, you run the package, it downloads and it installs. You do the same thing for the other packages. And you also have to take note that when typing these packages, you take into consideration the spellings and capitalization. If you type this W with small letters, you discover that, you know, R will tell you this package is not found, except there's another package which has that name. And when you install a package from online, it's not enough for you to use the package, because installing a package from online means you've just been able to download the package into your computer. Any different packages. So what you do is, for you to use a particular package, you have to load it or call it up from the library using this code. So if you type library in bracket, the name of the package, you're telling R that go to the library of packages which I've downloaded and get me this particular package, because that is what I want to use at the moment. Because maybe you have hundreds of packages in your library, maybe you need to use just one of them. You should be able to, you know, call this package from the library. So that is why you see these three codes here are the codes to call the packages or to load the packages from the library. So now we'll look at, you know, what Bernard explained on power calculation or sample size calculation using the using power in R for the one sample t-test. So here, what I'm doing here, I'm just making comments such that you know what I'm doing. You know, like for example, this is like a heading to the codes that I want to type below. So we use the power.t.test for sample size calculation in R for a one sample t-test. So we specify the type, if it's a one sample or a two sample t-test, and he explained to us what alternative is. You know, if we are considering if the difference in the mean of our group, is it different from the hypothesized mean or the mean we are considering as our standard mean, for example. So, and one thing with the software is it is very, very case sensitive. It means if here, where, you know, you have one of these commas and you make a mistake and it's not there, you run this code from now to tomorrow, you will never have a result. So when you're typing a code, it's supposed to be exactly the way it's supposed to be in terms of spelling, in terms of symbols, in terms of capitalization, and all of that. One of the things you don't need to bother so much is spacing, because no matter the space you give between two, you know, words or two quotes, it doesn't really affect the result. But the spelling of the different functions and the where you find the commas and the different symbols is very, very important. And if you look at the software, there is an option here. There is a green arrow here, which code, and you want to see the results, you need to run here, or the shortcut, you take Control Enter. So if I click on this, if I place my cursor on this particular line of code and I click run, it gives me a result which appears on this console. So I can decide to minimize this console. And this is a similar result to what Bernard had on his slide, with a sample size of 264.6138, which you can round up to 265. And of course, with this, so what the software does is, in the algorithm in the background of the software, it takes into consideration the mathematics. So R makes it very easy. You don't necessarily need to punch in all those formulae you saw, but it's important to understand what is happening in the background. So here you're just using the software to generate, to come up with your sample size. But again, you have to take into consideration all of the basics, the mathematical, formula he explained in order to understand what is happening, right? So you know what is happening, and that is what will actually guide you, on your significance level and your power and so on and so forth. So we run this, you have a result here, which gives you your n, which is the sample size. And a similar thing when we want to do maybe for a 2-sample t-test, where we have a significance level which is similar, and we specify the type, which is a 2-sample t-test, where maybe we're comparing the means between male and females, or the mean between maybe 2 different groups, right? Maybe we're comparing the mean between participants in 2 different regions, for example. So we might want to do the same thing, but the only thing we add here is to specify that it is a 2-sample t-test in R, so that R is giving us the sample size for each of the groups. And if we run this, we have a similar result to what he had with an N, or a sample size of 226.3. And this sample size is for one of the groups. So each one of the group has a sample size of 526. So you can be able to complete sample size for the entire population. And moving over to ANOVA, where we are comparing the means, or want to compare the means of more than 2 groups, maybe 3 different groups, right? Maybe you have male, females, and maybe bisexuals, like how we have now. We might also want to use the power calculation in R using the power.ANOVA.test function. So now, just a brief explanation of what this code is telling us. So this is the function to do the test. So it means that this guy, this power.ANOVA.test, is what takes into consideration those arithmetics and the maths at the background. And so if you type this wrongly, all what you're fitting in here, you're just wasting your time. So these are the arguments that you're fitting into this particular function. Here, which represents the number of groups and so on, and your significance level and the power. But this is the guy who does the job, because without this particular function, then you're doing nothing, right? So it's just like you want to get the mean of whatever thing, and you put in bracket, you give the numbers that you want to calculate the mean. If you put the numbers even 1 to 100, but if your mean is not well written, then it's like you're telling R that give me the average of some numbers, but you haven't specified the word or the function that it has to use to be able to get you that result. So if we run this, it also gives us a p-value, a sample size of 13.8 for one of the groups. And in this case, we're comparing the mean in 3 groups. So if we're considering the mean for 4 groups, our K will be 4 and 5 respectively. So if we're considering K to be 3, it means we'll have a sample size of 14 for one of the groups, and you can multiply that by 3 to get the sample size of the entire population. And also for test of proportion, where you're comparing the proportion between 2 groups, for example, we can also use this code. So let me just do this so that I have some more space here. So using the stated power, this function is also found, is still the part of the power. So power.prop.test function, and you specify the sample size n as null, such that arrow takes all of this and fits into the arithmetic operation formula, which we saw in Bernard's presentation, such that this is the variable that is lacking, such that when arrow calculates, it gives you this variable, or this is what we are looking for, and with the significance level of 0.05, like most statistical tests will consider. And when we run this, we have a sample size of close to
this one.
Yes.
Yeah, so maybe to answer what Miriam actually asked. So for example, for code line number 19 for power.ANOVA.test. So if you really want to even calculate the power, when you have the sample size and you want to see whether that sample size fulfills the power, so you'll just include n, for example, n, which is now 14 in this case, and just remove power. Then the algorithm will also provide you the expected power for your according to your sample size. So you don't even need to provide the power, you just provide now the n in your code, then it does the power calculation in the background as well.
All right, yeah,
Just
I think that is to the lady's question, right? I think that was answer Miriam's question also.
Yes.
Yeah. So Miriam, I think so. It's just like you have an equation and you make X the subject, and in the other case you want to make Y the subject. So in this case, maybe if you want to get the power and you already know the sample size, for example, you feed the sample size here and you consider the power as null, such that R is capable of giving you the required result. And for a chi-square test, which Bernard demonstrated, where you're taking into consideration the degree of freedom, and of course, let's say you want to compare if two categorical variables are dependent or independent of each other. Let's say maybe you're looking at gender and smoking. Males who smoke, females who smoke, males who are non-smokers and females who are non-smokers. Maybe that's the kind of study you want to take, you're trying to do, and you have to do a chi-square test at the end of the day. You might still use the power calculation for the chi-square test. You take into consideration the difference in the, the difference in the power as well as the significance level. And if you run, it gives you, a sample size, in the number of observations of 51.3 or approximately 52. And finally, we have that for logistic regression model, which is quite similar. So you discover that, it's quite similar to but the difference here is that we are taking into consideration here, we've mentioned the family, like he explained in the slides, and the alternative too, and also the power, which if you run this, it gives you the different proportions. Let me run this again. It gives you the different proportions and the beta naught and the beta one for the different predictors which you have in your model, and with your sample size of 202 if you round up. But this one thing now, so this one thing you have to notice that this already tells you, like Bernard explained, it means if you're designing a particular research study, which before you even go to the field to start collecting this data, you have to be able to consult a statistician, because a statistician is the one who will be able to take into consideration all of this, and you should be able to know the statistical tests that you use. Most often, especially back home here in Cameroon, where knowledge or applicable knowledge on statistics are still very limited. Most students go to the field, even at the postgraduate and PhD level, carried out their study, collect the data, come, and now they start thinking, what sample size or what statistical test do I need to use? But it shows you are supposed to have an analysis plan, know what you have to do with the data before going to the field, because the statistical test that you have to use is what will help you to know how to calculate the sample size of your particular study. And this is very, very important. And that is how you discover that, a lot of things maybe which people do out there tends to be faulty. Because if you have to go critically to look at, okay, did this person take into consideration the statistical test? How was the sample size calculated in context with the statistical analysis or statistical tests that had to be used? You discover that a lot of people are probably doing what is a lot, we can say, is questionable. Okay. So just that is just a summary of it. And like Bernard said, these things are open. You can get the link from his slides and you read more, such that you can see the different codes on how to calculate sample size, for the different statistical tests. So I just decided to demonstrate this on R so that you see how the interface of the software looks like and how we can be able to successfully run some of these codes in R. Okay, so I think that is that. And thank you very much, Ivo, and back to you.
Okay, thanks, Desmond. I'll just open the floor again if there are questions related to what Bernard presented or what Desmond showed with the arrow codes. Please, this is the time for it before we move to the final section of this event. So feel free to unmute yourself if you have specific questions related to the arrow codes, or maybe something you just remembered with respect to Bernard's presentation. Okay, I'll take the silence for no questions. But if you still have questions, you can drop the questions in the chat section. Desmond, thanks for presenting that. I will take over the screen so you can stop sharing. Okay. I really want to thank you guys. For those that are still here, still hanging, I really want to thank you guys. So I would just want to conclude this presentation with this. So like I mentioned at the beginning of in the agenda section, we have a special offer. And the offer we do have, it's a statistical analysis training program. I can understand if some of you are like scratching your head right now, if what Bernard presented is something I can absorb. I will definitely understand in 30 to 45 minutes is so it can be challenging to absorb what Bernard and Desmond explained. So that is why we have designed this program that will, in the program, the whole idea is to introduce you guys to statistical analysis concept from a real world perspective. It's not about the formulas. It's not about cramming formulas. It's about, learning the concepts. But for example, now Desmond can show you how to use arrow codes in order to simplify your life. So we're going to have this in 2 dimensions. So we'll have the arrow programming section and the statistical analysis section. So for the arrow programming, these are the topics we are going to cover for the arrow programming. I'm not going to go into details of that, but you can see it's quite a lot. So by the time you're done with this, with the arrow programming training, you should be comfortable enough to use arrow. I know Desmond just explained quite fast. It might look simple, but there's certain tricks you need to understand. So I believe with the guardians of Desmond, you should be able to be comfortable to use arrow in your research studies or whatever the purpose is. Now, it's not about for me, it's never about the software. I think Desmond mentioned there are so many of those softwares. Most of the time I use Python programming. So it's not about the software, it's about you mastering the concepts. If you see, most of the time you have to put in the parameters. And from what Bernard was explaining, there are certain calculations you have to do by hand as well. So you need the concepts. So we do cover the concepts. And I think it's a very good lineup. With this, I believe you can carry out so many research. There are certain research, especially maybe at the master's level, that you don't need to use any complicated statistical methods, except maybe you're going for PhD that you might have to do advanced. But I believe with this foundation or with this lineup of topics, you should be comfortable with a lot of research studies. Okay. Now, so what's the approach? I mentioned that the approach will be more like you give you the concepts and you do practicals. Very, very important. The practical aspects are so important. And the duration is, so we hope that this program is going to last for 6 to 7 weeks. And what are the target audience? Same. So you guys that are here, we are looking at students or graduates, researchers, all professionals, and anyone that is interested in statistical analysis. So these are the target audience. And, we also want to start this program early next month. So I think exactly almost like 2 weeks from today. So from the seed of November, and hopefully before Christmas, the Christmas break. Now, I know everyone is looking at me, hoping the obvious thing, which is the training cost, right? We have really considered this a lot, and we understand everything. And if you look at the material, it's a lot we have to cover. At the same time, we don't want to do something that it's going to be so expensive. That's why we have arrived at this amount. So this is the amount for the training. But if you're based in Africa, there's a 50% discount. So if you're in Africa, we give you a 50% discount. But if you're not in Africa, it's 300 euros. Now, so it is open as of now. If you're really, really interested, I hope you're interested. It's good for you to register for the program and get the concepts. I know part of the presentation says you need to involve a statistician at the beginning. It's also important that you understand the concepts, because if you bring in a statistician and you're telling about p-values, calculate this, you don't really understand anything, then it makes no sense. It makes the work of the statistician a little bit difficult. So for me personally, it's very important you understand the concepts to a certain level, so that when you're inviting a statistician to help you with your project, then you guys can easily flow. So this is the amount. So at the end of this event, or maybe like early tomorrow morning, I'm going to send out the registration form, and also some of the event materials which you can go through. I don't know if there are any specific questions with respect to the training program we are offering. Feel free to ask your questions now. If you have any questions with respect to the training program, anything that you, okay, I see Moses. Yeah. Moses, you can unmute yourself and ask your question. I think, yeah.
I'm speaking. Are you getting me?
Yes, I can get you now.
Yes, thank you. I am Moses and I'm from Kenya. Thank you for such a wonderful presentation. So based on the program that you are intending and your team is intending to offer from November 6th, just go to the previous slide.
Okay.
Yeah, that this one. So I can see we have R programming and we have statistical analysis. Are these different programs or just one program? Because maybe we have someone who is good with R, but is blank when it comes to statistical analysis. In short, he's not an analyst, but you know he can do simple plots, he can run simple queries in R. How does that one? How do you sort out that one? Or in short, are these two different or they're the same? We have R programming and we have statistical analysis.
Okay, so they are not like, it's not like they are totally different. So what we intend to do is like, okay, when, for example, Bernard will give you the concepts, then Desmond will show you how to do that in R. Okay, so it's not like separate programs. But I think if I understand you well, if you say, for example, I'm already very good at R programming, I just want to do statistical analysis. Is that possible? Is that the question? Maybe it's part of your question as well. So
Exactly.
Okay. So that is something we did not really think of, but I think it can be possible if you're sure that you're already very good with R programming. You just want to focus on statistical analysis, then we can figure out something because they are separate classes. So maybe Bernard will teach statistical analysis and you're not interested in R programming. Same wise, somebody might be, they can be someone here with a very good statistical analysis knowledge, and they just want the R programming. So I think it's possible. We should be able to figure it out. Yeah. Okay.
Okay, thank you. Thank you.
Thank you, Moses. Any other question? Okay, so like I mentioned, maybe tomorrow morning, I'm going to forward you guys the registration and everything concerning what we have done today. If you're interested, please, we have 2 weeks of registration period. So that's the time for you to make the decision. Or if you still have any questions specifically to what we have presented or to the training program, please feel free to contact us. Okay, I think by now you have received probably 2 or 3 emails from me. So you can obviously reach out at any time. No, okay, I see. Is that Ransom?
Yeah.
Okay, yeah, Ransom.
Okay.
Go ahead.
Yeah, I just would like to find out if is it who presented on statistical analysis? I don't remember.
It's Bernard. Yeah.
Bernard, right? If
Yeah.
his email is copied in the presentations or the emails that you sent.
No.
But I saw it on the screen. If I can have it, I would be very grateful. Yeah, because I would want to contact him personally because I'm also a PhD student like him. So yeah, we might have other things to discuss about.
Okay. Yeah, I will discuss with Bernard. If Bernard is okay, and then I can share with you his email address when I'm sharing the resources.
Okay, thank you.
Okay. Okay. So like I mentioned, Graffiland is all about, partnering with professionals to bring, knowledge to Africans globally. And have upcoming events. I'm the one doing the next one. So I'm more into the data science guy. So we have the next one on data analysis using Python, programming, and SQL. It's not really the statistical stuff like what Bernard is doing, but this one is more like for the business side of things. So I'm going to show you how to use Python programming and SQL in order to analyze data, not using statistical analysis, but more like related to business. Even though you can still use the knowledge you learn from here to apply in statistical analysis, because you're going to learn Python programming. If that is your interest, like I mentioned, Python programming and Arrow, they can probably do the same thing in statistics, but I'm more into Python and SQL. So this is an upcoming program. We'll have a session next week, Tuesday. It's me like giving an open house session, probably almost the same format like what we did today. So feel free. You can obviously register by scanning the code, and that's the registration link. I'm also going to share with you guys this flyer as well in the resources tomorrow. And last week we had a very, very good session on LinkedIn. And like I mentioned in my framework, based on my experience, no matter how you can be so intelligent, you can be so smart, that if you don't know how to brand yourself, how to sell yourself, you might miss certain opportunities. So we had a very good session on LinkedIn last week. And so we have another one coming up again on Saturday, 11th of November. It's more like it's hands-on. So Etona, she's a Ghanaian. She's going to show us how to really brand yourself on LinkedIn and sell on LinkedIn. Because, when I look at her profile, she's really doing a lot from Ghana. Sometimes I envy her. I feel like I have to go back to Africa because from Ghana, she's really doing a lot. So this is an opportunity for you to know how to use LinkedIn to grow your network, to also have that professional branding. I really encourage you guys to attend these two events if possible. Okay. I don't know if there are any questions specific to this, but like I said, I'm going to share the flyers. If you're interested, please just scan the codes or you click on the registration links. Now, based on the registration, we realized that a lot of people saw these events, the statistical events using on WhatsApp. So we also encourage you guys to join us, to follow us on our social media accounts so that you don't miss out on certain things. We offer like free, like you see, like what you just did today is free. So we do that quite often. So please feel free to check us on Facebook, Instagram, LinkedIn. You can even go onto our website. Even on Google, we're on Google as well. So please follow us on those social media platforms so that you don't miss out on opportunities. Okay. I think this is the last thing I wanted to mention. I don't know, Bernard, Desmond, are there any final remarks from you guys?
Not really. I think you've said everything already, and I just want to say thank you guys for signing in. I've been identified a few people like Ransom from the US, Chem Fomuni from the UK, and a few other people. So thank you guys for signing in, and looking forward to meeting you guys again in our subsequent sessions.
Okay, thank you so much. Bernard?
Yeah, for me, it's just to thank you guys for joining. And if you have any question, you can always reach out to me. Ivo can share with you our contact, and yeah, so there's no problem with that. And otherwise, I hope to see you again in coming weeks, if possible. And yeah, have a good night.
Okay, thank you. Guys, please just take, I think, 1 or 2 minutes of your time to answer the poll. There's a poll in the chat section. Just 3 questions, very, very quick questions. And while you guys are doing that, I can maybe just open the floor to anyone that has some remarks, maybe to, I don't know, just tell us how you feel about this presentation, or something that can really benefit those on the call. Anyone that is motivated to say something and why, and also please answer the poll in the chats.
Yeah, let me pick it.
Yeah, Moses. Yeah.
Yeah. Thank you very much. For me, from my perspective, being that I'm someone who deals a lot with data, especially the data that is being collected from the field by my colleagues who are in the field. At one point, I've always noted a lot of gaps, especially when it comes to sample size calculation. You find out that I think I'd once attended a field activity with my team because I support them remotely, but once in a while I go to the field, and if you look at the way they calculate the sample size, you see it's not something that I can talk of. I can say scientific. You just see them like saying, see in this area we have this population and we can take this kind of household, but you see the procedure of even getting these households and the exact number that they need is not scientific. So based on whatever Bernard has shared, turns out Bernard, I think Bernard is my personal friend, and we have always shared a lot in terms of data. So when you see whatever we have learned or gathered here, it's a bit scientific. It's something that you can write on paper, you can publish, and you can share with the professional. Again, big up Evo and your organization at large. I think one of the objectives of the program you said is to kind of network and involve like-minded individuals in the field of data. I know the 12 of us or the 16 of us who are in the call could be having an avid interest in the field of data analytics or data management. So it's good to network and to learn from each other, and even seeing that you guys have gone ahead and even sacrifice your time to organize kind of a boot camp so that you can impact other people with the kind of knowledge that you have. So it's good, and may God bless the work of your hands, and may God increase your skills so that you can keep on sharing and capacity building other people. Yeah, thank you very much.
Okay, thanks Moses for those kind words, and I think that's obviously Bernard and Desmond, they have received your message. And also just want to encourage everyone on the call, please, let's network. Okay, you see our social media accounts, let's network. And if there's something you have brilliant as well that you want to share, Ransom, I think. Okay.
Yeah, I just wanted to add that as a researcher, it is not a problem if you are not a statistician. So if I'm a researcher, for example, I can work with a statistician, collect my data and give it to a statistician to analyze it for me. And if I can be able to interpret that data, then that is what is important. So what am I saying? What I'm saying is that you guys can also consider to offer services in data analysis for graduate students. So it shouldn't just be about the training, because not everyone can be a statistician. Yeah.
Okay. Thank you so much, Ransom. That is something we're also considering. The thing that I just watched, if you remember, some of the services we offer is also AI and data analytics, and consulting is part of what we do. But I didn't really want to focus on that. But yeah, thank you for that recommendation. Okay. I think I've obviously take 2 hours of your time. I really, really appreciate all those who were still on the call. Yeah, so I will send out the emails tomorrow for everything, the resources, and if you're interested in the training program, please subscribe for the program. Okay, thanks so much, and wish you guys a good evening.